The last thing we're going to look at is rotational symmetry. Right, so here we have a figure rotating around the center of the figure. Right? So when you're rotating around the center of your figure, right, we can look at rotational symmetry. So when we rotate this particular figure, actually has no rotational symmetry, but we'll talk about what that means. But here we can see our figure rotating around the center. Right? And so there's two ways we can think of this. P is our center of rotation. We can either think of it as a 270-degree clockwise rotation or a 90 degrees counterclockwise rotation. Right? So I said this particular figure doesn't have rotational symmetry. Doesn't mean we can't rotate it around its center. We can definitely rotate it around the center. So let's talk about what rotational symmetry is. And this is in your notes. So rotational symmetry, a figure has rotational symmetry if there is at least one rotation of less than 360 degrees about a point so that the pre-image is the image. Right? So when we say about a point, it's going to be the center of the figure. There we go. All right, so think of the blades of a fan. Right? So here my fan has 3 blades, right? And it's rotating around that center point. This figure has rotational symmetry of 120 degrees and 240 degrees. Right? So that means if we, will this rotate or is this stuck? This one is stuck. Yeah, and I don't know if it will all be one figure. I'll try. So it's going to look a little weird because if I lift my pen up, it might not be one figure. So I won't lift my pen up. There we go. All right, so if I rotate it, oops. Well, we seem to have issues rotating around a point on this smartboard. There we go. Maybe it's me. There we go. All right, so there's 120 degrees. All right, so notice, right, that it matches up again. I didn't turn that thing a full circle. Right? I only turned it a third of a circle. So how did we know, I'm going to get rid of this thing. How did we know that it had rotational symmetry? How did we know that angle would be 120 and 240 degrees? And let's get rid of that thing. Well, if we go all the way around the circle, right? So if I start here and I keep rotating and I keep rotating and I keep rotating, right, that would be 360 degrees. Right, this is a very symmetric figure. Right? And there's 3 of these blades. So if I take 360 and divide by 3, that means each blade is 120 degrees away from one another. Right? So if I move a blade, one blade around, I get 220 degrees. 2 blades around, I get 240. 3 blades, I'm back to the beginning. Right? So a circle has the most rotational symmetry of all. It has infinite rotational symmetry, right? Because I mean, if I rotate a degree, there's 360 different ways I can rotate it. But what if I rotate half a degree, or a quarter of a degree, or an eighth of a degree? Right? So I can rotate fractional amounts of degrees. So a circle has an infinite number of infinite rotational symmetry. It also has, if you remember back to reflections, it has an and we were looking at lines of symmetry. It has an infinite numbers of lines of symmetry too. That's because the circle is just so symmetric. All right, so we're going to look at some more figures on this page and look at rotational symmetry. All right, so angle of rotational symmetry. Another way to describe rotational symmetry is by determining the angle of rotational symmetry. In other words, how many degrees. Radians is another way to measure angles. We're only going to be working with degrees around a circle that you have to rotate a figure so it is carried onto itself. Right? So that's what the definition of rotational symmetry is. All right, by the way, make sure on this last figure that you remember to show the rotational symmetry, right? And you should probably show 120. And then if you go this far, it would be 240. And then if you go all the way back, it's 360. Right, so just a little side note there. Let's go back to the other page. All right, so here we have 4 figures. They all have rotational symmetry. So if I rotate it around the center, right, so the center would be here, or roughly here, or here, or here. I'm eyeballing, especially that last one. All right, so we're rotating around the center. Right? And so literally you could just, if you hold the figure still in the center and just turn it around. All right, so how many degrees does it take? All right, so for that particular figure, it's going to take 180 degrees. All right, I'm going to have to go halfway around a circle to get, white and green. All right, so if I'm looking at this point here, right, I'm going to have to rotate 180 degrees to get to that position over there. Right? So if this is, I haven't rotated at all, and this is 180, we mapped it to itself. Right, so that has a 180 degree rotation it's going to take. This one will have a 90 degree rotation. Right? Each time, it's kind of like our fan, except this one has, and so now here's 180, and this one has 4 blades instead of 3. And then this one would be 270, and then we're back again, and that would give us 360. This one is just like the fan in a lot of ways. It's not shaped like the fan. However, the degrees is very symmetric. To go from this to the matching part over here is going to be 120. And then if we keep on going, right, we have rotational symmetry again at 240 degrees. Or we could turn it all the way back again, and we're back to the beginning. Right? So on our last one, this one has 72 degrees rotation. Now, how do we know that's 72 degrees? Right, so let's think about it. Right, let's keep going 72 degrees. Right, so if I go from here to here, it's going to be 72 degrees. This, by the way, is a regular pentagon. All pentagons do not have rotational symmetry of 72 degrees. As a matter of fact, the only pentagon that even has rotational symmetry is the regular pentagon. Only irregular polygons are going to have it. And so, oops, I meant to not write 72. Let's add the 72s, so that would be 144. Right, if we add another 72 degrees, right, that's going to be 216. And then we're going to add another 72 degrees, and that's going to be 288. And then we're going to add one last 72 degrees, and that's going to take us back to 360. Right, so how could we find how many degrees is it takes the first time to map onto itself? If you just take 360, because it's a regular polygon, and divide by 5, that's where the 72 degrees comes from. And then you can see that in our figure there. I probably should have given you these examples as well in your notes. I don't know if I could have squeezed them in. Not expecting you to draw them. Nice little surprise if you do. But last thing is order of rotational symmetry. So order of rotational symmetry is the number of positions in which a figure can be carried onto itself. And that's called the order of rotational symmetry, or simply rotational order. All right, so let's take a look at our figures here. All right, so this has rotational symmetry of 2. Right, it's going to be mapped onto itself not only at 180 degrees, but if I continue to go around again, all the way around the circle again, I'll be at 360. This one has rotational symmetry of 4. This one has rotational symmetry of 3. And this one has rotational symmetry of 5. a rotational order of 1 actually means the figure has no rotational symmetry. All right, so here I have my little heart here. And it does have a line of symmetry, right down this, well, not in that location. However, if I got a line tool out, it does have a line of symmetry right there. Right? That would be a line of symmetry. Let's see if I can clone my heart here. And then we look at rotational symmetry. Clone. There we go. But now watch if I turn this around. Right, see if you see a heart again. A heart facing the exact same direction. Right? So I'm rotating, I'm rotating, I'm rotating, I'm rotating. Then it's not mapping, it's not the same, it's not the same. It's not going to be exactly the same, not the same, not the same, not the same, not the same, until I come all the way around again. All right, so I'd have to turn the thing all the way around 360 degrees before I got the same looking heart again. On the other figures, for instance, on that pentagon, I only have to turn it 72 degrees and I've got the same pentagon. All right, each vertice there is going to map to the other one if I just rotate it 72 degrees. No luck with the heart. All right, so poor heart has got a line of symmetry, but it has no rotational symmetry. So if you just rotate the figure, you can tell whether or not it has rotational symmetry, whether it looks exactly the same, and whether it maps to itself again. Right? That's what carried onto itself means. All right, so that's it for me and rotations. Hope you enjoyed this series of podcasts. In the next series of lessons, we're going to be looking at combining our transformations. And actually, now that you've learned all the rules, that should go by pretty quickly. All right, bye for now.